Hello, welcome back. Let's start our last topic, which is angles of elevation and depression. So let's say that we have a helicopter that's approaching a runway, and he sees the air traffic control tower. Now, from the perspective of the helicopter, from eye level, he would look down to the air traffic control. That angle that he looks down would be called an angle of depression, because from eye level he's looking down, so it's like depression. Then at the same time, from the air traffic control tower, from his eye level, he would look up to see the helicopter. That would be what we call an angle of elevation. So angle of depression looks down from eye level, angle of elevation looks up from eye level. Now you'll notice these two eye levels are going to be parallel lines. Now they're not parallel to the ground because the ground's actually curved, right? They're tangent to the ground. Or another way we can say is that the radius going through the point directly below him or on the surface of the earth would be perpendicular. That radius would be perpendicular to that line. So you can think of it as eye level as being parallel to the ground, but keep in mind the ground's actually, not flat. So in this case, both of them, they're going to be parallel to each other because they're tangent to the same radius point that goes through to the center of the earth. And so they are parallel, meaning these two angles are alternate interior angles to each other, so they're going to be congruent. The angle that the helicopter looks down to the air traffic control from eye level is the exact same angle of elevation that the traffic control looks up to the helicopter. So let's look at an example here. Here we have Dusty Cropphopper and fighting forest fires. I think he's got all of his racing gear on and stuff from the end of the first movie, but whatever. He's fighting fires. That's the only transparent PNG I could find that I liked. So anyway, we have four different angles: angle A, B, and then X and Y. Which one of those angles would be an angle of elevation? So remember, an angle of elevation from eye level is looking up. So that would be angle X. Angle Y is not an angle of elevation. We actually don't use the angle Y. We don't measure anything off of the vertical angle, vertical line. We always measure off the horizontal line or the eye level. So we won't be using angle Y. Which angle is going to be an angle of depression? So from Dusty Cropphopper's eye level looking down would be angle A. So angle B is measured off of the vertical line. We don't use angle B either. All right, so let's say Dusty Cropphopper is flying and he looks down to the fire and he wants to figure out how far away he is from the fire. So if you look at the point directly below Dusty Cropphopper all the way to the fire, that's this distance X that we want to solve for. So one thing that he can do is he can look and see what his angle of depression is. So if he's looking down, this angle A, let's say that he says it's 30 degrees. So he has a 30-degree angle of depression, all right? And then he also knows what his elevation is. So at that time, his elevation is 10,000 feet, which is a pretty typical cruising altitude for light sport aircraft. All right, so he's cruising at 10,000 feet with an angle of depression of 30 degrees, and we want to find out what this length is here. Well, the problem is that the angle of depression is a part of the top right triangle and not the bottom one. The other two measurements are on the bottom one. So there's two things you can do. You can either move these to the top, move that one over there, or we know the angle of depression is the exact same as the angle of elevation, so we can actually move it down here. So it's this exact same angle that we have here going up. So the angle of depression going down is the same as the angle of elevation going up, which is pretty cool. So now I have the opposite side, which is the elevation of 10,000 feet. I have the adjacent side, which is the X, and then my angle here. So I'm using the opposite and adjacent. That would be the tangent function. So I'm going to use the tangent of our angle 30 degrees, which is our angle of elevation, is equal to the opposite of 10,000 feet divided by the adjacent side, which is X. Now when X is on the bottom, remember we have our shortcut. We just switch the order of these two. So what I'm going to put in the calculator is 10,000 divided by the tangent of 30. So let me pull up my calculator here. All right, so I'm going to do as a fraction, I'm going to do 10,000 divided by the tangent of 30. All right, which will give me 17,321 feet. So he is 17,321 feet away from the forest fire. All right, another example, which is pretty typical to what we'll be seeing, is a park ranger looks 20 degrees above eye level to see a hawk 400 feet above the ground. So if he's looking above eye level, that's an angle of elevation of 20 degrees. And he sees a hawk that's 400 feet above the ground. So the hawk to the ground is going to be 400 feet. how far away is the ranger from the point on the ground directly below the hawk? So from this point to where he's standing, that's going to be this distance here, which is the adjacent side. Now, the 400 is actually not a part of the right triangle. That's the entire thing. So we got to be careful. There will be a problem on the test like that. So if we see his eyes are 5 feet above the ground, we have to subtract that 5 feet from the 400, leaving us with this y component here, the opposite component, of being 395 feet. So be careful. Make sure you adjust that by the same 5 feet we have over here. All right, so on our right triangle, we have 395 feet is the opposite side. We have the adjacent of x and then our angle of 20. So we're relating the opposite and adjacent, which is the tangent function again. So tangent of our angle 20 is equal to 395 divided by x. And then again, when x is on the bottom, we use our shortcut, and we're just going to switch the order of those two. So when we put this in the calculator, it'll be 395 divided by tangent 20. All right, which means that he is 1,085 feet away from the hawk, the point directly below the hawk. All right, so that was it. Really, really short. Let's go ahead and get right into the assignment. So we want to label here our angles of elevation and depression. So looking from the perspective of the birds, looking below eye level to the cruise ship is going to be an angle of depression. From the cruise ship looking up to the birds would be an angle of elevation. And then look from the cruise ship looking down to the submarine is an angle of depression. And then from the submarine looking up would be an angle of elevation. So you can just label those DE, DE. You'll kind of notice a pattern for the other problems we have there as well for 1 through 4. On number 9, we have a person flying a kite with an angle of elevation of 40 degrees. So from eye level, 40 degrees. We want to know how high the kite is being flown if the length of the string is 125 feet. And this is actually pretty cool. If you go out and you know how long the string is on your kite, you can measure the angle of elevation using an inclinometer, which is also pretty cool. There's apps for that, by the way. And you can find out how high you're flying your kite with this method of right triangle. So this is actually kind of cool because this can be done. But also remember to add the height that you are above the ground as well, your hand where the end of the string is as well. So that would just be this component here. So we have the opposite, we have the hypotenuse. So we're using sine. If you notice, the one that we're not using on this one is the adjacent side. So we can't use the cosine or the tangent function. Instead, it's going to be the sine of our angle 40 degrees is equal to the opposite of x over the hypotenuse of 125. X is not on the bottom, so we're not going to switch them. X is on the top, so we want to get rid of division of 125, so we multiply both sides by 125, and we'll put that in the calculator. So 125 sine of 40, which will give us 80.35 if we round. All right, number 13. A child is standing across the street from his apartment. His mother is on their balcony. A child looks up at an angle of elevation 22 degrees to see his mother. If the distance between their eyes is 32 feet, then how far is the child standing from his apartment building? All right, so the distance between their eyes is 32 feet. That's going to be the direct distance between their eyes, which is going to be the diagonal here, which is our hypotenuse, in other words, is 32 feet. If the child looks up with an angle of elevation 22 degrees, looking up, the angle of elevation would be angle B down here, which is going to be 22 degrees. Now that's going to be the same as the angle of depression for the mother looking down from eye level, which would also be 22 degrees, by the way. Then the only other thing they ask is how far is the child standing from the apartment building. So from the child over to the apartment building is going to be this distance along the bottom here. We've got the adjacent side with respect to this angle, and we have the hypotenuse. So we're going to be using the cosine function. Cosine is the adjacent over the hypotenuse. So cosine of 22 degrees is equal to x divided by 32. Now 32 is on the bottom, x is on the top, so we want to multiply by 32 on both sides. So when we put this in the calculator, we'll get 32 cosine of 22. So 32 cosine 22, which is going to be 29.67. So the distance for the child between the base of the apartment and across the street would be 29.67 feet. Number 15, you stand 40 feet from the base of a tree. The angle of elevation from your eyes, which are 5 feet above the ground, to the top of the tree is 47 degrees. So how tall is the tree? So angle of elevation is looking up from eye level is 47 degrees. Your eyes, keep in mind, are already 5 feet above the ground. So we're going to have to add that 5 feet to the total height that we have here. So this height here, that's going to be the opposite side, by the way. That's going to be our length x that we're looking for. So we're trying to solve for the length of x here. That's our opposite side. We have the adjacent side already for the 40 feet. So the trig function we're going to be using relates opposite and adjacent, which would be the tangent function. So tangent of 47 is equal to x divided by 40. So we multiply both sides by 40 and we put it in the calculator. So nothing really too tricky here. We're just doing the same process over and over again. So 40 tangent of 47, which will give us 42.90 if we round. So 42.90 feet, but then keep in mind we're going to have to add to that the original 5 feet. So if you don't get that on the answer bank, that's what we forgot to do. So we're going to take our previous answer and add 5 to it. So if we push the A and S button here, that'll give us our previous answer plus 5, which would give us, I mean, obviously 47.90, which should be on the answer bank. All right, number 20. An airplane is flying at an altitude of 10,000 feet. The airport at which it's scheduled to land is 50 miles away. Find the average angle at which the airplane must ascend for landing. Keep in mind 1 mile is equal to 5,280 feet. So on this one we have our altitude of 10,000 feet. That's going to be this length here. Essentially we're going to say that it's landing at ground level, so we don't have to worry about the difference between the altitude where it's flying and the altitude of where it's landing. Also, it says the distance that it's landing is 50 miles away. That's not going to be the hypotenuse length because they don't actually measure the distance for airplanes like as the crow flies, the actual distance that they're traveling. Instead, they measure the distance that is along the ground or at sea level above where they're flying to their location where they're landing in this case. So that's going to be 50 miles. And then we want to find the angle of the descent. So the average angle of descent is actually going to be the same, like an angle of depression is the same as the angle of elevation. So we can just use this x down here, not a big deal. So we have the opposite side, which is 10,000 feet, the adjacent side, which is 50 miles. Notice these are different units, one's in feet and one's in miles. So I do need to convert this side to feet so that they're, or divide this side to get it to miles. Either way, just make sure that they're in the same units before you calculate it. So we have the opposite and adjacent, so we're going to be using the tangent function. So the tangent of our angle x is equal to the 10,000 divided by the 50 times the number of feet that we have in a mile. So that'll change that to feet. All right, so the x in this case is stuck inside the tangent function. So just like we did yesterday, we have to undo it using the inverse tangent. If we take the inverse tangent of one side, we have to do tangent inverse of the other side as well to keep it balanced. Those two are going to cancel each other out because they undo each other because they're inverse functions of each other, leaving us with x is equal to the inverse tangent of all that stuff. So that's what I need to put in the calculator. I go to the function button and then inverse tangent. I'm going to put it in as a fraction. 10,000 divided by 50 multiplied by 5280. And I need to delete that one. Okay, so that's going to give me an average angle of descent of 2.17 degrees if I round. Number 22, last problem I'm going to do with you. So on this one we have a diagram here. We want to know the height of the tree, I believe. Yes, so just like the other one I did. We have an angle of elevation from our eyes is 61 degrees. Our eyes are 4.5 feet above the ground. So we are going to have to add that 4.5 feet to the overall height that we have here when we're done. Remember, this is the opposite side that we were solving for here, which is the length in x. All right, we also have the adjacent side, which is how far we are standing away from the base of the tree, which is directly below the highest point of the tree. We will actually go outside and do indirect measurement like this, so it's kind of cool because you need to know where the highest point of the tree is because it could be all over the place. All right, so we have the opposite and the adjacent. We're using the tangent function like we've been doing a lot. That's going to be x over 55. And then x is not on the bottom. We just have to multiply both sides by 55. So put in the calculator as 55 tangent of 61, which is going to be 99.22. And remember, we have to add 4.5 to that when we're done. So I'm going to take the previous answer, which is A and S, and it'll kind of paste that for you. And I'm going to add to that plus 4.5, which will give us 103.72 if we round. So 103.72 feet is the total height of the tree. All right, so pretty simple stuff. The only difference is angle of elevation and depression is from eye level looking up or looking down. So the same stuff using inverse trig and regular trig functions. I know it's a lot of review, get to be a little bit repetitive. Hopefully the assignment's not too long, and you got some different types of problems and different diagrams and pretty stuff to look at. So let me know if you get stuck on anything. Can't wait to see you guys again in person. We got 2 games we're going to do next week, and then the test before we have spring break, so that'll be fun. Then when we come back, hopefully I'll have you guys for 5 days in person. You guys will be able to meet the students, the other classmates from the A or the B schedule, so looking forward to that. And let me know if you guys have any questions.